Now coming to our process called SWAT. This is SigmaWeld Accelerated TIG. It's basically a keyhole TIG process. It is used for automated welding and is extremely efficient TIG welding process. There is no edge preparation required. It can be used with or without filler wires. You can have square butt welding, that is no edge preparation, up to 8 millimeters, and low heat input and very, very low distortion. How this particular thing works? It's a keyhole TIG. So what is keyhole is basically the arc is so concentrated and powerful that it punches through the whole thickness at one go. And that's why it's called keyhole. It forms a keyhole and then it moves and it carries the keyhole with it. Here the arc is constricted. Constricted means this is your normal TIG arc is this big. We are concentrating the arc in a very small area. Okay, it's more focused on a smaller area, which means you have more penetration. And the power sources are in the range of 500 amps and 1000 amps. How much of a difference does it make by constricting the arc? If you look at the table here, in a normal TIG machine with the same parameters, your arc voltage of about 10 volts or 9.8 volts and a current of about 100 amps would give you an arc force of 3.2 millinewton. That is here, the arc force available to melt the pool. Now, when you constrict the arc force available is 9.2 millinewton in the same current voltage. So you can imagine you took all the energy that was being divested here and you focused it onto a smaller area. Therefore, you have more deeper penetration, lesser heat affected zone, and more concentrated arc at one position itself. This is the kind of profile you get on an 8 mm sheet. So this is called a wine glass profile. How does this appear? Is with the help of this focused arc, you would have a very concentrated arc. The arc punches through the keyhole. On the other end, what you see here is it's called an effects plasma. It takes all the gases and it exits from the other end, and that gives you a clear picture that there is 100% penetration happening. Okay, and it obviously, because of the molten pool, it also shrinks the material amongst each other, and therefore you get a reinforcement and you get the entire structure here. I'll just show you two quick videos. This is where we have mounted a torch on top of a column boom, very square butt welding. The plates are placed here, and you will see a linear motion at the speed of about 400 millimeters a minute for this 8 mm plate, and the welding will finish well within a minute's time. So this is the normal speed of welding here, and as you can see, there is no filler wire or anything given to the torch, right? And what is happening on the other side, that is below the 8 mm thickness, is you will see a plasma coming out like this. This is the efflux plasma, which is showing all the gases and all the things are coming down from the other side, which means you have a 100% penetrated joint.
So sorry to interrupt.
Yeah,
purging is not required in this process?
Purging is required, sir. Purging from the bottom is given by argon. There will be also a trailing shield which will be given, because if you don't use a trailing shield, you can see slight oxidation because the speed is very high for the normal cup to cover the area. So typically, based on the travel speed, you have to extend the trailing shield also, so that you don't get these slight oxidations on the surface. But these tests have been completed with all section 9 and there is no problem with the configuration.
Fine.
Right?
Okay.
These can be used for long seam, circular seam welding, and also on tube mills. This is one which we had integrated with the tube mill. What kind of materials we can do? We can do stainless steel, we can do duplex stainless steel, titanium, nickel alloys, stellite alloys, and carbon steel. But carbon steel we are yet under process, because there is, with each batch of carbon steel or mild steel, there is a change in the chemistry, which means that the consistency of weld, the heat pattern generated is not there. So for carbon steel, we don't recommend so much as we do it for stainless steel, nickel, stellite alloys, HESTA alloys, and your titanium.
Okay.
We did do some 6 mm thick titanium long seams for Godrej, and we could get very good results in single pass. And titanium is a very reactive material. So you can imagine if you can reduce the number of passes of weld on titanium, it's a very big advantage.
Yes, sir.
What do you need is you need a Pro Series power source with SWAT mode inbuilt. You'll need shielding gases. For stainless steel and alloy steel, you need argon hydrogen mixtures, either 2.5%, 5%, or 10%. Then you need for duplex stainless steel argon nitrogen mixture. Purging gas is used as argon. Trailing gas is also argon. And we do use a chiller unit just to keep the torch cool because these are continuous cycle machines, and they work at very high currents, so about 400-500 amperes continuous. So the torch needs to remain cool. So we use a chiller unit. And for anything above 8 mm thickness, we use cold wire feeders just to give you the capping finish. And otherwise, it's a slight, there is a underfill. It's not an undercut, but even if there's a slight underfill, you can use the cold wire feeder just to top it up. The kind of speeds you can guess for SS304L that we've already worked with, I'm sorry, is we did all the Schedule 10 pipe in the tube mill, right from 2.72 to 8 millimeters thick. And sorry again, we could get speeds of 815 millimeters for 2.72 and up to about 400 millimeters at 8 mm. So this is the kind of speeds you can achieve. We also are doing some trials right now for LNT for 10 mm and 12 mm, where we are making a small V on the top and leaving a root face of about 8 mm. Again, a square butt joint and straight welding, and it covers up the other passes as well. Right?
Yes, sir.
Tube mill application, as I was sharing, we've already tried it. So typically, whatever you're using plasma plus stick combination, you could replace it directly with the SWAT and a single torch. Earlier, the speeds on the tube mills were about 175 millimeters a minute for a 8.5 thick 12-inch dia pipe, which now they were producing at about 300 millimeters a minute at 475 amperes. Single torch, single process. Mind you, all these pipes that we did do for the tube mills were subjected to RTR. They passed all the configurations of flaring, bend, and radiographic tests, and they ran for non-stop multiple shifts. So once started, it does not need to stop, kind of an application. You can see the consistency in the weld bead and the penetration here. The surface is polished, so I can't show you the top bead, but you can see the penetration all throughout. And same here, the flaring test or the weld, and this is a macro of the same. Now, if you're doing long seams and considering about 8 mm thick plate, a single 1 meter means in manual you have to do 4 passes. So you need to do 4 meter long welding. Manual speeds are about 55 to 60 millimeters a minute, which leads to about 72 minutes of weld time per meter, right? 30 minutes of welding. Edge preparation time, you want to, do the grinding or the beveling. Same thing if you want to do in automated TIG, that means 2 passes, 1 root, and then capping or fill up root with weaving. Your speed would be about 100 millimeters a minute, and you could do this job in about 1 hour, 1 meter length. In SWAT, this would take 300 millimeters a minute, and you would finish it under 5 minutes because you don't have any edge preparation. This is a case where we did Hestalloy C276 material. This is 6 mm thick and 6 meters long. No edge preparations have been done. And this is the pre-welded distortion. So you can see the plate being kept pre-welded. And this is post-welding. This is the root penetration achieved. The time taken to finish this joint of 6 mm thick, 6 meters long is under 15 minutes. This is the video of the edge preparation that you can see. It's a square butt as you see here. No root gap. They are both placed next to each other and the torch will move straight on this long seamer. Now here is the actual video of the weld happening. So you can see it started from here and it's going straight. The speeds here were about 420 millimeters a minute. And you can see in the top as the leading part, there is it's a completely square but no root gap kind of a joint, no edge preparation. And if you see here during the welding, it's continuously welding at the back. As sir had correctly pointed out, you will need a better trailing shield to just avoid more cleanup at the end. But if you're going to do buffing, all this will come away. This is only surface. Okay. They have been subjected to various Section 9 tests like your root bend, face bend, tensile, and RT, UT, all of those. And they have passed all these tests consistently for all these materials we discussed.